Hey guys, welcome back to our channel. Today we're going to solve the problem leaders in an array, right? So we are given an array of positive integers and we have to find how the number of leaders and who are the leaders in that array, right? So by definition of leader is that any element we can call it as a leader if all the elements to the right of that element are lesser than that element. Right? That means if I'm saying 17 is a leader, it says all the elements to the right, that is 4, 3, 5, 2, are smaller than the 17, or we can say 17 is greater. Similarly, 5 is a leader because 2 is smaller. And the last element will always be a leader because there is nothing to the right of it, so it always be a leader. Okay, and we have to return back this array. Okay, and also the sequence should be preserved. Basically, which appears first, that is 17. We have to, while returning, we have to return in the same order, right? So we have understood what is the problem statement. Now let's think how many possible solutions or how we can approach this problem. So now let's take this example that we are given the array 16, 17, 4, 3, 5, 2, right? And let's search who are the possible candidates of the leaders, right? So by definition of a leader, we have to check each element if it is the maximum and all the elements to the right of it are smaller, right? So the most obvious or brute force solution can be like we can start from our element 1, that is 16, and we can check each element from 17 to 2 if this element, let's say we start from 17, so this 16 we have that we are comparing and the other is 17, right? So while comparing 16 and 17, we can see that this 17 is, one second, I think I'm very bad in writing. Yes, so while comparing the 16 and 17, we can see that 17 is greater. And if 17 is greater, that means we don't need to check 4, 3, 5, 2. Because by definition of leader, this 16 should be greater than all these elements, right? So 16 is not a leader. Now comes to the next element, that is 17, right? Now let's check from this 4, 3, 5, and 2. So comparing 4 and 17, 17 is greater. Yes, we can move to the next element. Now 3, 17 is greater than 3. Yes, we can move to the next element. Now the 17 is greater than 5. Yes, we can move to the next element. Then 2, 17 is greater than 2. Yes. So we have checked 17 with all the elements on the right and we can see that 17 is a leader, right? Now let's move to the next element, that is 4. Okay, so for 4 we need to check 3, 5 and 2. 3 is greater than 4? No. So it's fine. We need 4 to be greater to be a leader. 4 is greater than 5? No. That means we have found a greater element than the 4 to the right. So it means 4 can't be our leader. Now next element is 3, right? Now let's check 3. 3 is greater than 5? No, that means 3 can't be a leader. Now coming to the 5, check 5. 5 is greater than 2? Yes. So 5 can be a leader. And by default, 2 is last element, 2 is always the leader because there is no element on the right, so 2 is always a leader. Right? So what we have done is we are starting from the first array, like from the first index, that is first loop will run from I till 0 to n, and after that for each ith element we are running one more loop to check all the elements on the right. That means I plus 1, and we will go till the end, that is I plus 1 till n, and here I'm assuming this n is the length of the array, right? So we will get our answer, and considering the time and space complexity, as we are using two nested loops, so the time complexity will be around of n square, right? And here also this n I'm assuming is the length of my array, and we are not using any extra space, but we are using this space for storing the answer. So if anybody asks about all the space, then you have to say this is O of n because you are using an extra space to store the answer. But mostly to store the answer, if we are using any space and we have to return that answer, we can neglect it and we can say the space complexity is of 1. But still keep this in your mind, we are using extra space, so you have to tell to the interviewer that if we have to count the extra space that we used for the answer, then the space complexity will be of n, right? But here we are using n square time, right? That is quite a lot. So let's think how we can optimize this. So now we have got our solution using the brute force approach. That is the first random approach that came to our mind, right? Now let's think to optimize it, right? What we have done in the brute force is we take one element, right? Let's say I take this 16 and keeps on checking this 16 with 17, 4, 3, 5, 2, right? So we can change this, right? Because to make it a leader, this should be greater than all the elements on the right. So what if instead of checking the 16 with all the elements, it's better, right? We calculate who is the maximum here, right? So let's say the 17, 4, 3, 5, 2, take the max. Like whoever is maximum come out, because see, if here we take the maximum, then obviously if 16 is greater than this maximum, then obviously it will be greater than all the elements, right? So we can take the maximum, that is 17. If 16 is not greater than 17, that means 16 is not a leader. Similarly, if we take 17, right, and to check it is a leader, we can take the max of this array 4, 3, 5, 2. So instead of checking, comparing 17 with 4, 17 with 3, then 17 with 5, then 17 with 2, and basically you're wasting our time, right? Comparing 17 to each element. Better take the max of this 4, 3, 5, 2, and just like the max is 5, and compare 17 with 5, and we can see that 17 is greater. That means it is the leader. So this is our idea now, okay, that we can use to maybe we can optimize it from this approach. Okay, so what we can try now is, let's start from the right, because we know we need to have the maximum from the right side, right? So let's start from the 2. Okay, now we are starting from the 2. So let's have a max variable which will give us the max element, right? Let's say for now we are checking with 2, and 2 is the first element from the right side. Let's say till here max is 2, right? Because we are starting from 2 and right now the max is 2. Now let's go to the 5, right? So whenever we come to an element, we will first check if this 5 is greater than max. We will check because we are maintaining the max now. Yes, it is, right? And if it is greater than max, that means now for this sub array 5 to max should we need to update. Now the max will become 5, right? So 5 is greater than max, we can take 5 is a leader, right? Now coming to 3, we will check, is 3 greater than max? No, 3 is not greater than max. That means 3 is not a leader. Now coming to the 4. 4 is greater than max. That is 4 is greater than 5. No, 4 can't be our leader. Now check 17. Is 17 greater than max? Yes, it does. So 17 will also be our leader. And as till 4, 3, 5 to 5 is the max. Now till 17 to 2, 17 is the max. Now let's check. 16 is greater than max, that is 17. No, so 16 is not a leader. And by default in the beginning we are taking 2, so and default right element is always be a leader, so we have to put 2 also, right? So this instead, so what we have changed in brute force and this optimal is, instead of comparing our leader with each element, we are just comparing it with the max, and we are trying to maintain a max variable. That's it. Nothing much we have done. But as in my question statement, it says we need to preserve the order of appearance. 17 is appearing first, then 5, then 2, right? But as we have iterated from the right side, we are got the in the reverse order. So what we have to do is we have to reverse this to get the correct order. That is 17, 5, and 2, right? So this we have to do. Now here we are just looping through ones from the right side till it is 0 index. So the time complexity of this will be of n, right? And we are not using the extra space, but to store the answer we have to use extra space. So if interviewer asks you about extra space, then you have to clarify that this extra space is of answer, and if you don't consider this, then I'm not using an extra space, so my space complexity at that time will be of 1, otherwise of n. This you have to explain and clarify to your interviewer, right? So now we have understood or tried all the approaches that we can think of. Now time is there to code this up. Now let's get back to our code editor. So now we are back to our code editor. So let's see what is the input. We are given a number array, that is A, and a number, that is the length of the array, and in return we have to return an array, that is our leaders array, right? So let's start. Right, we need to have a max variable. Yes, correct, as we have discussed. So let me initialize it with the minimum value, that is minus infinity. Right, now I need to store my answer. So let's say this answer array I am initializing because this array I need to return. Right, now I need to start from right and check for leader with max and keep on updating max, right? This is my task. So I will do a for loop, that is, let's say I equal to 0, not I equal to 0, this time we are starting from right, so I is n minus 1, and we have to reach go till the 0th index and then I minus minus, right? So what we need to check is if my current element by any chance is greater than equal to my max, right? That means I have found my leader and I need to push this in my answer array, right? And now as this array of I is greater than max, that means we have found a new max. So let me update the max, right? So in answer array, we got leaders, but we need to preserve order of appearance, right? That so reverse this. That means we need to reverse this, and to reverse this I can simply do reverse answer dot reverse and return this, right? Now let me run this and let's see if we have any compile issues or no. No, the answer is fine. Let me submit this solution and let's see what we have got. So it is processing, yes. So all the test cases have been passed, and that's the approach, and we can code this way. So if you guys have any doubts, let me know in the comment section. I tell you this every time. So again, if you have any doubts, mention me in the comment, write down your issues. I will solve this up. And if it is clear to you, just write in the comment that it is clear. I will be more happy to read that out. So that's it for this video. We'll see you in the next one. Bye bye. Thank you.